Going live. $20 delay. Okay, now we are live. It's been a long time since I didn't do a video, simply because I worked on other projects which are not public. But this time I will do a fix, actually. So, the last video I made was about my USB cable tester, micro USB cable tester, this device here. And so, what does this device do? It actually checks if cable is there to transfer data, if it's a real USB cable or something else. For example, this USB cable here, if I plug it in, up, and there's no battery, I need a battery here. Without the battery, it won't work. There's no free energy. Up. You see that there are 3 LEDs telling that this cable is capable of transferring power, data, and has a shield cable. This is a good USB cable. If I now take this cable, if I press it, if I plug it in, I see that this is only for data and for charging. And I cannot, for data, for power and for charging. So this is really a charging cable, which are given away for a lot of USB devices, or USB chargeable devices with batteries. So this is where you get this cable. And because I was annoyed that I kept, for example, accidents using these cables for, oh, actually this is not marked, using these cables for transferring data and not knowing why doesn't transfer data, is my device broken or not, I decided to make the micro USB cable tester, and all the details are actually in the QVOODOO video. So I won't explain exactly how it works and so on. Just watch the QVOODOO video. What's the theory behind? So this is a charging cable. So I will put C on the back of this cable. This way I know that this is a charging cable. Only a charging cable. So this was the first prototype, hand soldered. I had only 10 of them because, yeah, I just made them. And because I had 10 of them, and I only needed one, I did give away, well, not give away, I did sell them. And they are sold out, so it seems that there is a demand. So, and because there is a demand, I decided to change it, to make more of them. And this is hand soldered, so there are a lot of things which are not good here. For example, two-sided parts, so we cannot two-sided the parts on both sides. So it's not very good for manufacturing because you would have to put it 2 times in the reflow oven or solder it by hand twice. Solder it by hand. So this was not good. So I had to put all the components on one side. The problem is that this battery is super large. This is a CR2032, so it's 2 millimeter thick and 2 centimeters diameter and 32 millimeters thick. So it is quite large. So I had to first solder the connectors, trim the leads of the connectors, and then put the coin stand holder so it's flush, else it will not be flush anymore. So this is a lot of handwork. But these were just prototypes. This is fine. This was not mass production. Now I did my mass production, which is hand. And you see there's a huge difference. I will just look at, so I have 90 of them. The problem is that they have a defect. I didn't put a lot of attention and I make a mistake. Let's have a closer look, and you can already see a mistake. So I did a lot of improvements first. I used surface mount parts. You see this connector and this connector, these are surface mount now, so no hand soldering. This coin cell holder is also surface mount, no hand soldering. So compared to this required hand soldering, this part and this part require hand soldering. This is surface mount device. Now everything is surface mount device. And for these connectors, although they are surface mount, they have some tabs inside it, and I wanted at least 2 tabs per connector, else they are just too flimsy. This is meant to connecting and unconnecting with a lot of force, and if you have no connectors, particularly for micro B, it just gets ripped off. So I wanted some with tab connectors. But so now and they are surface mount. Although they are through hole, this is just paste in hole. So they should just add paste and put the connector on it, and then don't have to solder by hand. And you see by how clean the soldering is, you see the level, although it might be hand soldered, could be hand soldered, or maybe selective solder, but because this bump is a bit higher, I don't know why, but they should work with pastes in holes, so there's less assembly. And also I switched, because I can't have the coin cell on the back, I switched to on the front, and now I have a teeny tiny CR 1220, so it's 1.2 centimeters diameter, and then 2 millimeters thick. But this is plenty enough. You don't use it, you just plug it for a couple of seconds and then remove it. This battery is sufficient for this task. And I also used this kind of holder on the side holder, because the top holder like this take a lot more space. You see, because of the plastic, because of the tab, they use more space, and because of the height also. Because this thing is not in a device, I can put the battery from the side, and this is what you see here. The battery is on the side. You can insert the battery on the side. Now the device has a couple of mistakes. So I produced plenty of them. Yeah, produce lots of them. But they have a mistake, and you see the mistake is this: I switched the LEDs for on the go and battery charging. If we take this cable was for battery charging, and if I plug it in up, and this is quite reliable, if I plug it in, you see that the original yeah. This is also fixed. Let's take a board which is not fixed. Up. Here, you see that I put battery charging on top and over on the go on the bottom, and you see that this would light up the on the go. So this is fixed with a sticker, but I will not fix these boards. I don't know what I will do with these boards. I will probably give them away for free. So if I meet someone, or if you meet me, just ask me, and I'll give it away for free. I cannot sell these devices because of this mistake. I mean, it's a simple device. You don't want something with a sticker. It could be useful, but it's my bad. I didn't pay attention. But I also fixed a couple of other things. For example, and this is what we'll see today, the improvements. One of the improvements I did already on the layout is this connector should be put a bit more to the, at least to the left, so it hides the mouse bites, so you don't touch the mouse bites. When you plug it in, connector is on top of the mouse bites. So I fixed this switch of LEDs. I also moved, so here you have mouse bites here, here, and here. For holding on the panel. Actually, on two perpendicular side, it's not a good idea because they're really hard to break off. I made panels out of 3x3, but this was a very bad idea. It is very hard to break out. I can also use a depenalizing tool or a sort of clamp, because here this connector is on top of the mouse bites, so you don't feel the mouse bites when you go with the finger. That's the purpose. So it's fine to have mouse bites. I don't want to clean them because it's too much time spent on a device which is pretty inexpensive. And this is why I put the connectors over the mouse bites, so you don't feel them when you go with your finger. This is also why the battery is a tiny bit over the edge, so you don't feel the mouse bites. So I can break off the individual ones from the panel. but having on perpendicular side was really a mess. It's very hard to break out. I cannot snap it by hand. It's really solidly in there. So I will change it, and I will just add the 2 mouse bytes here, and I will hope that my manufacturer is able to manufacture it this way. Else I'll have to find a solution. But yeah, so this will be fixed for the next panel. So this was a problem. So breaking off here takes a lot of time. It's not good. But yeah, if you meet me, I will give them away for free. I cannot use them. That because of this issue, I will not put sticker on all of them. Did put some sticker on some of them, but it costs too much time and it looks really ugly. Now, the thing why I've enabled to stream is I want to also fix the LEDs. Here, there are only red LEDs. Here, there are more colors, so it's easily identifiable. And if I connect this, you see that power is on red, like it always should, and then which battery charging is on yellow. But if I connect over the go adapter, up on the go adapter, not over the go, this is white, and you see it is a lot more bright than the yellow was. So I need to dim change the resistors. I didn't bother, I just put 1K resistor everywhere. For the red, it's quite fine, but when you have different colors, having the same value is not good because all the LEDs have a different 4-volt voltage drop. And for the same current, they also have a different luminosity. The white is it's a lot more luminous. And it's a lot more luminous, brighter, it's brighter. And if we have a look at this cable, you see that actually it's not very, no, it is visible also on the camera. The blue, so we have red for power, green for data, because this is good. Then I have shields on blue for extra good. And then on the go is on white and battery charging is on yellow. And you see here that the blue is too dim and the green is too bright, and I want to change it, and this will be our task today, and this is why I enabled the stream. So I have this part, and then I will just switch the resistor. So I desoldered the resistor for the green one, which is data, which is data, and then we will use just this is, yeah, the overhead LEDs, the overhead things. And then I looked at I have SMD books, something like, well, you see it here, SMD books with lots of resistor values for 06, 03 in inches. But I don't have a lot of devices between 1 and 2K, and I think this is the range I will use. So instead, I will use the trim pots. I will solder trim pots, and I will just change the value until it fits my eye and it looks nice. Why do I have okay, this is a gone battery. So the data size is nice, but I made a mistake. I can't solder them, and instead I will improve them a lot. Also, what I will change is this. I've put a QR code on the bottom, so you have access to the manual, but also to the source files, so the schematic, the mode of operation, whatever you want, the Gerber files, so you can produce them on your own. The problem is that this is white on green, so white on background, so this is an inverted QR code. Not every app is able to scan inverted QR code, so we'll change it for manufacturing, and I will put black on white or something not inverted, which all apps should be able to decode, because my app is not able to decode. So it's not able to decode white on black, the inverted by default, but you can change it in the settings, and if you change it, then it works. But I don't want to change it. I want all QR code scanners to be able to scan the device. And now for testing the values, I just used a 5K trim pot which I will solder, and I will I will change the value until I find something fitting. So here we have 2 legs. Up. Let's put the cable and let's dim the green so it matches the red. I will use the red as a reference value. I don't know why. I thought that the brightness for the eye is high enough for it to be clearly visible. Something is not so, yeah, this isn't soldered. It is bright enough for the clear to be visible, and yeah, we just have to use one standard, and I will reference everything to the red one. Let's put more solder. And I will do it for all LEDs this way. I will always change up. So here we have the green. The green is too bright. And oh no, actually it's not too bright. This is the right value. I don't know what value I used by accident, but this is a nice value. What if I change it? Did I use the 2 wrong legs? Yes, I used the 2 wrong legs. This is 5K, isn't it? Can I use the multimeter and measure the resistance? No resistance? Yeah, it's 5K. 5K? 5K for green? But yeah, I did solder the wrong part. I like the color. I didn't expect, I was something like 2K or something like that. It might be a bit dim, but 5K is really good. Or is it 4.7? Ah, let me switch on the multimeter so you can also see the values. This goes here, up, multimeter. Is it on? Up, up. Multi-dashboard, UT. Yeah. Can you read the values? Yes, you can read the values. And now I need tools. I'm just opening my browser so you can also see multimeter values. Home automation. Up, measure, measurements. Here they are. And up. Yeah, the power supply is not on. I only value here. So if I if I now use this and try to measure, I cannot measure in circuit because it does drive some voltage or some current, I don't know. We see, yeah, 4.7. Kilo ohm. And 4.7 looks nice. It's a tiny bit dimmer than the red, but it, yeah, so for the green one, I will use 4.7. Let me write it down. I didn't expect it to be so high. I thought something like 2.5, something like that, so half the brightness. But 4.7 is quite nice. Paper and pen. I have 20,000 pens here. Red, this is the standard. It's 1K. Green 4 dots. It might look a bit brighter on the camera, but because the camera is just changing. Yeah, it is. It is a tiny bit less bright than the red, but that's not noticeable. And 4.7 is a standard value. I prefer, just for the fun of it, to use standard values. I'm sure you could use any value, but I'm happy with that. So let's do the next LED, which is the shield LED, which is not bright enough. So let's all unsolder this resistor. Okay, gone. This is unsoldered. And now I actually need, so on the trim pot, it's between these two legs, right? Yeah, 0, 2, between these two legs. So let's try to solder them. I could do it this way. This is not enough. I think this is 22. Okay. So what's the resistance? 200. 200 is probably not enough, but we'll test it. 200. And there's also the internal, oh, you didn't see. There's also the internal voltage. Let me switch the camera a bit here. There's also the internal resistance of the battery. This is a coin cell. It has a huge internal resistance. So I didn't solder correctly. This is why. Oh, actually, there's too much spring tension. Let's just add plenty of solder. Okay, now huge blobs of solder. It doesn't look nice, but it works. Let me change the camera angle a tiny bit. And then there should be also a bit more. Can I change it so there's less? Yeah, less reflection from the top lights. Yeah, I think there's less reflection from the top light now. A tiny bit less reflection. Good for me, bad for the camera. So we are at 200. Now it should be working. At 200 should be too bright. So let's check it. That's not too bright. Oh, I lifted the pad. Oh, this is too bright. So let's try it. Now this is too bright. This value around here. And we will change it on a board and have a look at how it looks like on a final board. Something like this. Yeah, this looks nice. What is this value? And we'll use the closest matching. Whoa, 4 ohms. Okay, let's try to switch it a bit higher because this only relies on the resistance on the internal resistance of the battery. Let's put something like 100 ohm. Blue, so the blue LED will take most current, 100 ohm. But it's also the one which is the nicest because it means that the cable has a shield and it is a good cable. I even lifted the pad. The yellow is not bright enough, so next one, the white one. This is the on the go. The white one is too bright, so let's put it to 5K. Oh, something like high value. Ah, this is so that together. Yeah, 3.5K. Damn it. I thought because it was leaded that it is not fine soldering, but in the end it is a 0603 resistor. Hup, this is on the go, so let's use the on the go adapter. Zoom so we can see a bit more the color. But normally this is weird because the white one was too bright, but as far as I know, the white is a blue with a phosphorescent coating, and the blue uses a lot more. Maybe it's just this blue. But I also need to transfer power, else I don't have any reference. But I cannot switch on the power. So my reference will only be my memory. Ah, no, my reference will be another of these devices. Up. Check. Check. It's a bit too dim. Let's turn it on. And the yellow is too dim. I also need to change this value. And I think this way is making it brighter. No, this is good enough. Bit too bright, maybe. Somewhere here. Yeah, somewhere something like this. So what kind of resistance is this? So normally you wouldn't want to have different. I used one resistor because first I had only red LEDs. Then I changed from only red LEDs, and actually the one I sold don't have only red LEDs. They have different color LEDs. But normally you don't want to have different resistor values, because different resistor values mean different parts. So for the assembly you have different reels and you pay per reel. So this is quite expensive, and you want to consolidate to everything one LED and everything one resistor. It makes it a lot less costly. But the assembly house I'm using for the prototypes, actually they have standard SMT parts which are in the pick and place machine no matter what. So I don't pay anything for the additional wheels, so I can use almost any resistor value and any LEDs. So these are the only LEDs which are available, but I can use any resistor values. I didn't find any other color LEDs. I used all of them which were available, and I had to spend a bit of time to check the. That's 1.6K, so let's put 1.5. 1.5 is a standard value. White 1.5, and this is why I'm taking the luxury to have different LED colors and different resistors, because I don't pay anything for it. If I would need to pay anything for this, I will just put everything the same color and the same resistor. It's a lot easier, and there is no marking next to it. It's just a feature to have colors and to be easily identifiable because I don't have to pay for it. And next, the yellow one. Up, and the last one will be the yellow one, and then we will make a prototype. Well, I do have 90 of these, which I won't use, so we can make plenty of prototypes. And again, if you meet me, I'll give them away for free. Or actually, if you order something, just add a comment. So the shipping cost is, I cannot cover for the shipping cost, but if you pay for the shipping cost, I'm happy to send them away. So if you buy something, if you buy one of them which will be fixed, just ask for it and I'll give you another one for free or more. Can't use them. Okay, yeah, does it short anything? No, it doesn't short anything. Almost, but it doesn't. Let's try with the cable. Up. Up. Check. This is yellow. This is, yeah, this is even less bright because we are at 1.5K. So let's try to turn it up. This turns it up. This is bright enough right here. A bit, tiny bit more bright. Something like this. Do you see the reflections again? For my eyes, it looks kind of similar. And yeah, for the battery charging, it's because in the cable it is internally shorted. So D- and D+ are internally shorted. This is why I don't have to plug the other end for this to light up. Tack, tack. And what value is this? 0.5K. So 470. Yellow. Yellow, 470 ohms. Is 1.5? Yeah, I think 1.5 is a standard value. I use it very often for USB. So this was the prototype. Let's make this out of one board. Let's remove the resistors and let's add new resistors. And I hope I do have an SMD book with lots of values, so there should be enough values. I should have all of them. I also have a box with common values, and I'm sure I do have all of them which are required, else I'll use. Up, desoldered. I do have some desoldering tweezers, I'm just too lazy. And I will just heat up both sides of the pad. If it doesn't work, just try with flux or try with solder. So yes, you can add solder to unsolder. It's a very common technique because you had more heat capacity. Up. And better contacts. Up. Okay. Tweezers. Now let's get the values. We wanted to try for green 4.7 or 5.1, but not 4.7. I'm sure I have 4.7 somewhere. So up here, I do have two boxes for SMD parts. I have both here resistors 0603 under 1K and over 1K. And here I should have 4.7K. So my resist. Why don't I have 4.7? I thought it was a common value. Maybe 5.1 is a better value. We need 1.5, that's for sure. Yeah, we need 1.5. This is 2K, 4.7K. So 4.7K. And when you buy 10,000 of them, so you have, or 1,000 of them. How many thousands of them? And I'm sure I will never use this reel completely. I don't do any assembly. I only do hand assembly. Okay. Could add some flux. Do we have? Yeah. Let's add some flux to the pads so it solders nicely. I have no idea what they used. What kind of solder they used. It went boing. Let's heat up the tip so the flux can go out slowly. Okay, this is flux. It's a bit cold here. Resistor, like always, bottoms up. Have bottom facing. Let's use this trick. Up. If you have SMD parts which are flipped all the time, you can use some surface which is bounceable, and when you press on the bounce, then it flips it. Small trick, so you can flip the parts easily. And actually the values I'm using are for these LEDs, so I'm sure, well, most same color LEDs use the same chemical, so it might match for other LEDs, but it doesn't have to. They might have complete other characteristics. So I won't say if it matches for your LEDs if you decide to reproduce and solder on your own, because the schematics and the PCB will be available as soon as I sell them. Until then, they're not available because don't need to bother. It's time publishing, and when it's not released and I only have the device, is it really important? And I'm not the only one working on it. So data is there. It looks ugly. Let's try to center tiny. Yeah. By centering, I was too eager. Come on, it's just a resistor. Why do I have so many issues in a resistor? I will add all the solder. This solder I don't like really. Lead-free solder. I hope it is. I think it is. Yeah, lead-free is a pain to solder. Oh, where's the resistor? Okay, resistor decided to disappear. Let's use another one. Oh, but I added some solder, so it's not lead-free anymore. So it's just me not being skilled. So how I normally do it? Yeah, let's do how I normally do it. Let's clean the solder away from one pad up. Let's clean the solder away from all the pads. Add some solder on one pad. Up. Then the resistor one side, heat the solder, let it cool, and put solder on the other side. Okay, it works nice this way. It's not straight, but it holds. So blue 100 ohms. What do I have? Let's try 220, 0 ohm, 20, 22, 100. What's the next value? 100 again, then 220. 100 is really not a lot. But yeah, I've already increased it, so yeah, I'll deal with 100. 100. Namely, I use them as inline protection resistor for signals. I want to protect any device. I use 100 ohm inline protection resistors. Okay, that's 100 ohm soldered. On the go, 1.5K. It's this one, 1.5. This is a standard one for USB pull-ups. I think it's on D+. You pull it up to indicate that you are a high-speed device, something like this. And on USB-C, you need even more resistors to indicate that your device, how much you can draw, or if you're a source, how much power you're able to deliver. I am not talking about power delivery. It's just normal cable. And battery charging, 470. This is, I should have 470, 330, 470. Up. 470. And I see that you're not watching at all what I'm doing. $170, and I'm okay with that. I will update the BOM so that the manufacturers uses these values. And plus minus 1%, I have absolutely no interest in that. Plus minus 5% is plenty enough. I don't need precision resistors. The eye is not that trained. This way, okay. Up. Now the sticker looks ugly, but I don't care. It's just a demo prototype. Let's clean up the flux residues. I'll actually remove the sticker. Let's remove it. Oh, it holds better than expected. Come on. Up. See? I switched battery charging and on the go. Rookie mistake. Don't know how this happened. Just didn't put any attention. I thought it was too simple. So always make a prototype before making a production. Just check if everything is okay. Oh, that's my lesson from what I learned. Make a prototype before you make a production. The prototype is okay, hand soldered, then you can make a production. This was a complete relay layout, and I should have made mistakes. I was sure that there would be mistakes, but I didn't care because of the price. I mean, it didn't cost so much to have them produced. I wanted to try out the panelizing service and the assembly service. I'm okay with it. It's okay. It's not always clean. The back is not very clean. So let's try it out. Everything is cleaned up. Let's try the cables. On the go. Doesn't work because there's no battery. Where is the device? Here. I need a battery again. Up. Give me a battery. Up. Tiny battery. I think it's one of the tiniest batteries. The other ones are like the LR14 are 1.5, so I cannot use them because most of the LEDs are over 1.5. I need something with 3 volts at least. Oh, wait. Is it a problem on the... it was not just a problem on the battery. I don't know. Is it a problem on the connector? No. Battery contacts? I don't know. Okay. White looks okay. It's not too bright. It looks okay. Now, the red and yellow for the battery charging LEDs. Where is the battery charging cable? This I need later on. This I don't need anymore. Battery charging cable. Yeah. Battery charging cable. Yeah, it looks nice. Red and yellow. Around the same brightness. Right is a bit more bright than yellow, but it's not noticeable. Well, it's not noticeable. It's not a huge difference. It's fine this way. Now, this is the most important one because here we change 2 LEDs and they're next to each other, so we clearly see the difference. And one of these has not been soldered correctly. Oh, it's been soldered. Okay, let's try again. Up. Oh. Now you see that the did I use 100? The blue is a tad bit too bright, but the green one is it's too low. For 7K, no. Oh, the blue one is also okay. The green one is not good. For the 7K is too high. I could trim down a tiny bit the blue and put 220. Let's try 220. And for the data one, let's try something like 2K. The green one. So 220. 100, 220. Just to try to save some current, because else it draws a lot of current, and the battery is quite small. So it only has, I think it has 38 milliamps, a standard one of these batteries. Which one is it? This one. Up. I don't reuse the resistor command there. It was nothing. I just put it in the bin. Up. So that's the green one. Let's try if the green one works and looks nice, or if 220 is too dim. No, 220 looks tiny bit dim. A tiny bit more dim than the green one. But maybe than the red one. Let's try to change the green one and see if it makes a visible difference. But 220 is like twice the current less, so it's a good thing. I don't want to. This is, let's try 2K. I have nothing in between. I think 2.2. Oh, 2K. I don't know if 2K or 2.2. I think 2.2K is a common value. 2K is a less common value. I don't know why I have 2K maybe for divide. But I mean, SMD resistors, you get them in any values now. Almost any value. For not too much money. Up, that's one side. Let's solder the other side. Up. We solder this one side because there was not a lot of solder. Now there is a blob of solder, which doesn't look nice. Let's try again. Check. Oh no, it looks nice. 220 is nice. Red, green, blue. And I want it to be RGB to have the right indication. It's a tad. The blue one is a tad too dim. It's hard for you to see, but for the eye, it looks fine. It draws twice less power. It's a nice step in between red, green, blue. No, it looks nice. So let's have 2.2 for the green, and for the blue one we have 220 ohm or 2K. I tried 2K, but it doesn't change too much. There's 10%. So we have the right values, and now it looks nice. I need to change that. So instead of putting a sticker, I will just put an arrow to say that. Does this work? Yeah, to say that these are switched. Okay, this is a stupid pen. I don't want to waste my time on you anymore. Does this side now work? It also doesn't work. Don't waste my pen in the trash bin. It works a tiny bit, but cost me too much time. And this way I know. So I'm happy with the values. I will change it in the BOM. Yeah. I will change it in the BOM, and with that I can then panelize everything again, but only with 2 tabs, and I hope that with only 2 tabs on this side, and I hope that the panel manufacturer will be happy with it. What is this? This looks ugly. Here we have some flux residues. I didn't check all of them. No, it looks really ugly. We do have flux residue on the bottom. They don't clean the boards. I'm not sure if it's visible on the camera, but we have flux residues. So no, they do solder the bottom apparently. Else there wouldn't be so much flux residues. Yeah, and it doesn't look too nice. Does it look consistent? No, they solder by hand. Oh, that's weird. They should have to. These parts are meant to just mount soldering. And how does another board look like? Yeah, again here, flux residue. Here also flux residue. It looks awful. Flux residue, flux residue. They don't clean their boards. I can't give it away this way. I will have to wipe them. Flux residue. Here this is a bit crooked, but not on all boards. Here we have again flux on the board. Let me show you. I don't know where this flux comes from. here also flux. Is this selective soldering? I have no idea. And is it the same on the all panels? No. Here, no, it's not the same. I have no idea what's happening. Here is flux residue, here too. On this board there's only flux residue here. There's absolutely no flux residue here. On this board there's no flux residue. I have no idea what's happening. Quality is very inconsistent, but it's cheap. And again, it's a prototype. I'll still have to clean them. Maybe using a wipe and then try to remove. It's not too important, but I can't give it away like this. And I can, yeah, you can stack them nicely. So, but this is done. So this was a short stream. I will do the bomb and then the order a bit later on. I'm not sure if you want to see this. It's just clicking and a lot of clicking. There's no hardware, just standing in front of the screen. Maybe you want to see my bomb order process. No. For now, this is done. The stream is, yeah, the stream is finished. And yeah, I will try to make the order today. No, not make the order today, because you always make mistakes. Prepare everything ready for order, make the order the next day, because it might be that you forgot something and only the next day you will remember that there's something wrong. So only do the, I will only do the next day. It's not, doesn't have to be so fast. But that's it. So yeah, that was the end of the stream, and you will see an update of this another time. Enjoy.